situation when this is not in standard form. So when this is not equal to 1, what do we do? So what should I divide by to get this equal to 1? So what we're going to do is always divide by whatever this equation is equal to. So this is equal to 36. We need to divide by 36 to get this equal to 1. And what you do to one side, you have to do to the other. Okay? So here we go. Now, this is going to turn into 1, right? So my new equation, we have 1 over here. And now, leave this as a fraction. Reduce 4 over 36 is 1 over 9. So y squared over 9. And then 9 over 36 is 1/4. So we have x squared over 4. Okay. So in this case, which one is a squared? This is a squared, the bigger one. Okay. B squared would be this one. So a is 3. That means b is 2. And plot those. So a, we're plotting on the y-axis, right? So we're going to go to 0, 3, 0, negative 3. And then b, we're plotting on the x-axis. So 2, 0, negative 2, 0. And here's my fancy little ellipse. And I'm not going to run through the whole finding the foci. Obviously what you're going to do is 9 minus 4 equals c squared, solve for c, and just label them. And it's going to be, the foci will be on the y-axis because this is the major axis. It's the bigger one. Okay, moving on. Now, this is what we're going to do. Write an equation of an ellipse given these characteristics. So again, we're working with ellipses whose centers are 0, 0, the origin, and now they're going to give us some information. So my suggestion to you is to always graph what they give you. That will help you. So 0, 7. So your vertex is 0, 7. 1, 2, 3, 4, 5, 6, 7. Oh, all the way up here. Now, if this is one vertex, where does the other one have to be? The opposite end. So 1, 2, 3, 4, 5, 6, 7. Alright? So that means this is going to be my major axis if the vertices are here. So now let's graph the co-vertices. 1, 2, 3, 4, 5, 6. So 0, negative 6, that means I have one at, negative 6, 0, that means I have one at 6, 0 also. Alright, let's draw this guy here. Just drag him over. Okay. Pull this up, put it a little bit down. Alright. So, my standard form, again, is, need my pen. Okay. X squared over a squared plus y squared over b squared equals 1. Okay, so this one is, okay, so this is, it has a vertical major axis. So actually this is reversed, so let's erase this. So my major axis is vertical, that means a squared is going to be under the y squared, right? So let's erase this right here. Let's just change this up. Sorry. My fault. Alright, so this is b squared and this is a squared. So everyone sees why that's happening, right? That's because the major axis is vertical, so that means a is going to be here, the larger number. So the a is what here? In this case, it's 7. So we have 7 squared. And then b is negative 6. So we have negative 6 squared, right? So what are my denominators? We have 36 and 49. So all you're going to do is plug in what they gave you, alright, into the standard form. So our final answer would be x squared over 36 plus y squared over 49, and that's equal to 1. Alright? Now, we need to graph this next one. So problem B, here, the only thing that's different is they're giving us a focus instead of a co-vertex. So what we're going to do is, let's pretend that, let's just draw in my axis here, right? So let's plot what we were given. We have -4, 0, right? And then we have 2, 0. Okay, so if this is one vertex, and that means my other vertex is at 4, 0. If this is one focus, then the other focus has to be here. Okay, so this means that my major axis is horizontal. So we have x squared over a squared plus y squared over b squared. And that's equal to 1. Okay. So, what's a squared? If our major axis is horizontal, that means a is 4, right? So 4 squared is 16. So that means we know one part of our equation. We're just missing one thing. We're missing b. So a squared 16 plus y squared over something, we're looking for this guy, equals 1. Now, we're given C, right, the point of our focus. So we said that we know that the focus, right, is a squared minus b squared equals c squared. So we know A and we know C, so we can find B. Alright, so a squared is 16. We already have that. So we have 16 minus b squared equals c squared would be what? C is 2, so 2 squared is 4. Alright, let's subtract 16 from both sides. So negative b squared equals negative 20, right? No, negative 12. Sorry. Okay, now we're going to divide by negative 1. Divide by negative 1. B squared equals positive 12. So if I take the square root, well, actually, you know what? We're looking for b squared, so we don't have to take the square root. Just take this guy, plug him in. So here's my final equation. Alright. Now, we're going to do one real life problem, and then we'll be done. So they give you this ellipse here, right? So let's just draw a set of axes here. Now, they tell you that it's 1,060 feet long, so this whole thing is 1,060, and the height here is 890. So how would I find this distance right here? If the whole thing's 1060, then what we would have to do here is divide by 2. So if we divide 1060, divide this by 2, we find out that this is 530 here. Okay, now to find this, we'll do the same thing. Divide by 2, so that means that this is 445. Okay, this is the 3. Alright, now, that means I know that this is A, this is B, right? So the equation for part A would be x squared over 530 squared plus y squared over 445 squared. So all you have to do is find a and b by dividing by 2 and then plug them into your equation. Equals 1. Now for part B, they want you to find the area of the ellipse, and they give you the formula, and you just need a and b, and we found that in part A. So a is 530, b is 445, so just plug those in. A equals, so we're going to have pi times 530, right? So times 530 and times 445. And that is equal to approximately 741,000 square feet. Alright, see you in 10.5.